when you're solving a system of 3 variables, you can use both substitution and elimination. If we look at this one, the third equation is the easiest. We already have a variable solved for. We know that z equals 2. So what we can do is take that 2 and plug it in for z in the second equation, because the second equation only has 2 variables in it. So if we take this 2 and we plug it into the z, we're going to end up with y plus 2 times 2 equals 0. So y plus 4 equals 0. So if I subtract 4, y equals negative 4. So now I know 2 of my variables. I know that y is negative 4, and I know that z is 2. So now I can go to that first equation, and I can plug in y and z and solve for x. So x plus 2 times negative 4 plus 3 times 2 equals 6. So x minus 8 plus 6 equals 6. X minus 2 equals 6. If I add 2, I get that x equals 8. And now that I have x, y, and z, I'm going to write my answer as an ordered triple, and you want to put it in alphabetical order. So our answer would be 8, comma, negative 4, comma, 2. And so you must get all 3 variables and then write them as an ordered triple. So sometimes it's going to be a little more difficult. So when we look at this example, you have 3 equations. So what I like to do is I like to label them. So this is equation 1, equation 2, and equation 3. Basically what you're doing is you're looking at all 3 of them, and you're trying to see what's the easiest variable to get rid of in all 3 of them. So in this case, y looks like it's the easiest. So we're going to take 2 equations at a time and get rid of the y's. So I'm going to take the first 2 equations. So I'm going to take the x minus y plus z equals negative 1. And I'm going to take the x plus y plus 3z equals negative 3. And I want to get rid of the y's. So since they have opposite signs, I can just add them. So when I go to add them, x plus x is going to give me 2x. Negative y and positive y will cancel out. That's what I wanted to happen. Z and 3z is going to give me 4z. And negative 1 and negative 3 gives me negative 4. So I'm going to circle this, and we're going to come back to that later. So we used 1 and 2. So now we need to use the last equation that we didn't use with one of the other 2. So it doesn't matter if we use 1 and 3 or 2 and 3, but we need to use 3 for sure. So I'm just going to take 2 and 3 and put them together. So I'm going to take x plus y plus 3z equals negative 3. And then I'm going to take 2x minus y plus 2z equals 0. So like I said, it didn't matter which one you used, 1 or 2, with 3. But because the y's are opposite signs in 2 and 3, I picked those so that way I can add the equations. If I want to use 1 and 3, I would have to subtract the entire equation. So now I'm going to add all this. So I get 3x. The y's are going to cancel. I get 5z. And I get negative 3. So now I'm going to circle this one as well. So once I have my 2 new equations, these 2 equations only have 2 variables in them. So now this is like a regular system. So what I'm going to do is take these 2 and I'm going to stack them up and I'm going to do elimination with them. So step 3 says solve equations from 1 and 2 for the 2 variables left. So I'm going to take my 2x plus 4z equals negative 4. So 2x plus 4z equals negative 4. And I'm going to take 3x plus 5z equals negative 3. 3x plus 5z equals negative 3. And now I want to do regular elimination here. So it doesn't matter if we get rid of the x's or the z's, whichever one is easier. I'm going to go for the x's. So what I'm going to do is I'm going to multiply the top by negative 3 to make that a negative 6. And I'm going to multiply the bottom by a positive 2 to make the bottom a positive 6, so they'll cancel. So this is going to become negative 6x minus 12z equals positive 12. And then this equation is going to become 6x plus 10z equals negative 6. So now that my x's are opposites, I'm going to add to cancel them out, so those are gone. So negative 12z and 10z is negative 2z, and then 12 and negative 6 is 6. So I'm going to divide by negative 2, and I get that z equals negative 3. So once I get what z equals, we're going to plug that into one of the two circled equations. Okay, we don't want to plug it back to one of the original ones because the original has 3 variables. We only want to plug it into one that has 2. So you can pick if you want to plug it into 2x plus 4z equals negative 4, or if you want to plug it into 3x plus 5z equals negative 3. So I'm going to take the z and I'm going to plug it into the first one. So I'm going to do 2x plus 4 times negative 3 equals negative 4. So we're going to solve this for x. So 2x minus 12 equals negative 4. I'm going to add my 12. So 2x equals 8. And then I'm going to divide by 2. So I get x equals 4. So now I have z and I have x. So now I can go back to my original 3 equations, pick one of them, plug in x and z, and solve for y. Okay, so it doesn't matter which equation we use. I'm just going to use number 1, the top equation. So I know x and I know z. So I'm going to plug stuff in. So my x is 4. I don't know y, so it stays minus y. Then I have plus z. So plus, and my z is negative 3. And then equals negative 1. So this is just going to be 4 minus y minus 3 equals negative 1. I subtract 4 minus 3, I get 1. So 1 minus y equals negative 1. I subtract 1. Negative y equals negative 2. So if I divide by a negative, y equals 2. So now I have y, I have x, I have z. So my answer has to be written as an ordered triple. So I'm going to have, in alphabetical order, x, which is 4, comma y, which is 2, comma z, which is negative 3. And then this is my final answer. So here we're going to first label our equations so we know which ones we're using. So we have 1, we have 2, and we have 3. If I look at all 3 of them overall, the z looks like the easiest to cancel out. So I'm first going to use equation 1 with equation 2. So I have 2x minus y plus z equals 4. And then I'm going to use equation 2. And that's x plus 3y minus z equals 11. So since the z's are opposite signs, I can just add these together. So I have a 3x. I have a 2y. These will cancel. And then I have 15. So I'm going to circle this, and I'm going to come back to it. So now I have to use the third equation. Okay, I can use the first and the third, or the second and the third. So I'm going to use the first and the third because the z's are opposite signs. So that's easier for me to do. So 2x minus y plus z equals 4. And I'm going to use that with the third equation. So 4x plus y minus z equals 14. So now I can add these together. So this is going to give me 6x. This one minus here. So now here the y's are going to actually cancel out, and the z's are going to cancel out. So when I add this, I get 18. And now I can solve right away for x. And I get that x equals 3. So this actually kind of cuts my time down. If you did 2 and 3, you'd get another equation, and then you would have to stack the 2 equations like the previous problem. But with this one, since I know x is 3, I can go right into the circled black equation and plug 3 in for x. So it would be 3 times 3 plus 2y equals 15. So 9 plus 2y equals 15. 2y, if I subtract the 9, I'm going to get 6. And then I divide by 2, y equals 3. So now I know y is 3. So now I can go back to any of my original equations and plug in x and y. So we'll go to the first one, and I'm going to do 2x, so 2 times 3, minus y, which is 3, plus z, because I don't know what that is, equals 4. So 6 minus 3 plus z equals 4. So 3 plus z equals 4. So z equals 1. So now I know x, y, and z, so I'm going to write it as a ordered triple. So x goes first, then y, then z. And then this would be my final answer.